All right, guys, it is now 10 o'clock, so we will go ahead and get started. So just wanted to start out by saying thank you so much for everyone attending. We know that due to COVID-19, we're having to look at training opportunities differently with our customers. So we wanted to offer some virtual training opportunities that allow you to stay connected with us and then allow us to answer any training needs you might have. So we did one 2 weeks ago on steel support systems. This week is grab sampling. Then in another 2 weeks, we'll have another webinar on hose selection and troubleshooting. And then after that, we'll have another one on regulators. So that's kind of the upcoming lineup. So stay tuned on our website and you'll be receiving emails about how you can join those as well. And then with all of these training webinars that we're doing, we do record them and they are also available on our website. So after this presentation, you'll receive an email with today's recording and then you can access some of our other recordings that way as well. So just a few housekeeping things. If you will, please make sure you're muted throughout the presentation. Since we have so many people online, just to kind of cut down background noise and that sort of thing. But we definitely also want to encourage you to ask questions as they come up. So rather than unmuting yourself and asking it kind of in the moment, we're asking you to utilize the chat feature. So if you hover over your screen, at the bottom of your screen, you'll see a little chat bubble. You can easily just click that and ask your question, and I will make sure to read those as we get to a good stopping point. So definitely want to encourage you to utilize that. Now with that, we'll go ahead and get started. Want to give a little bit of background information about our presenters today. So we'll start with Matt. Matt Dixon is a senior principal design engineer for Swagelok on the custom solutions team. He's been with Swagelok 22 years and has extensive experience in sampling systems. He worked with developing the GSM and GSL product lines and Swagelok's ammonia sampling system. So lots of good experience there. Next, we have Karim Miraz. He's the product manager for Swagelok's analytical instrumentation line. He's been with Swagelok 12 years and has also held roles in manufacturing, engineering, and custom solutions, as well as serving as the product manager of general industrial valves and regulators. Then we have Eric Kuvarda, who is a principal design engineer for Swagelok, also on the custom solutions team. He's been with Swagelok 26 years and has specialties in offshore chemical injection and hydraulic control systems, oxygen system design, mechanical seal support systems, grab sample stations, and more. So lots of good experience from our presenters today, and we're just really excited to let them share a little bit more about grab sampling with you guys. So with that, I will hand it off to Matt.
All right. Well, thank you very much. Really appreciate the opportunity to share a grab sampling experience with the team here. So let's start out. Let's talk about what is grab sampling. So grab sampling, as most of you are probably aware, is where you go out into the field and take a sample out of a pipeline, tank, or whatever, and take that back to the laboratory for analysis. This is in contrast, of course, to like an online analyzer where you're actually doing that analysis right there in the field. With grab sampling panels, there are a bunch of different types, but very broadly speaking, they really boil down to two very basic types of panels, two very basic types of sample containers. One would be sample cylinders, so panels designed to take a sample in a sample cylinder, and the other would be for bottles. And when I say bottles, that could be a glass bottle, it could be a plastic bottle, it could be a metal can, whatever the case may be. It's really about whether it's a closed sample container or whether like a cylinder or a bottle, like where it's not necessarily intended to be pressure containing. Grab sampling panels are known by a lot of different names. Sampler is probably one of the more common ones, lab sampler, field sampler, but that all amounts to the same basic thing. So why are we actually taking a sample? There are a lot of different reasons why you might need to take a sample. One is, of course, to validate the process conditions, making sure that the product that you're manufacturing meets the specification, either at the end of the process or some point in the middle of the process, coming out of one unit and heading into another unit, making sure that you're delivering product as expected. It could be that you're validating online analyzers. So for example, anytime you have an online analyzer installation in the field, chances are you have a grab sampling installation as well to validate the results of those analyzers periodically. Loading platforms is another popular one where anytime that you have a change of custody, very often you're going to be taking a reference sample so that you can go back and analyze that sample if need be later on if there's a problem. And finally, of course, environmental concerns are growing. Of course, no matter where you are in the world, regulations are only increasing with regards to emissions and things of that nature. And so we need to be able to track those things. So measuring the flare gases and things of that nature is definitely one of the great applications for grab sampling. With all those different applications, you're going to find these samplers in a lot of different places around your facilities. Whether it's at storage facilities out at the tank farm, could be on transportation lines between facilities or from one unit to another. It could be on the process lines within the facility. We just mentioned the environmental aspects, so monitoring the emissions coming, your flare gases and things of that nature. And then we also mentioned the process analyzers and validating those process analyzers. So what is the difference between grab sampling and an online analyzer? There are a lot of different pros and cons in terms of one versus the other. So let's take a look at some of those. So grab sampling, one of the great advantages is it's much less expensive. You're able to have multiple grab sample panels all feeding a single analyzer that's back in the laboratory. So the cost of the grab sample panel and the cost of that installation of that grab sample panel is significantly less than when you have an online analyzer. It can be generally installed much closer to the process. So with a grab sample panel, it's relatively small. You can fit it usually within a few feet of the process line, or at most maybe 50 feet away. With an online analyzer installation, of course, it's generally going to be installed in some sort of a shelter, and you have to be able to find some real estate in order to build and install that shelter. So those are generally going to be much farther away from the process, from the sampling point. And also it allows you to concentrate your laboratory expertise in the laboratory, your analytical expertise. So you don't have to distribute that throughout the facility and have those experts going around all throughout the facility to maintain and take readings from different analyzers. Now, of course, there are some drawbacks to grab sampling. The biggest one is time delay. With an online analyzer, you can get essentially real-time results. The gold standard for online analyzers is that you can get a result within 1 minute of extracting that sample from the process. So with grab samples, obviously you can't do that. There's a significant time delay between when you take the sample, when you collect it in the sample container, and then by the time that sample gets transported from that sample point back to the laboratory, and then it has to be in queue in the laboratory, and it could take hours or sometimes even days before that sample actually gets analyzed. So there's some significant time delay associated with grab sample relative to online analyzers. It's also harder to maintain the sample at the process conditions. Even though it's relatively close to the process, by the time you get it into that sample container and now you have to transport it and again wait through all that time delay, it's harder to maintain that sample in the phase and temperature and pressure conditions at which the process is. So it might not be representative anymore. And it's potentially more dangerous. By their nature, grab sample panels introduce human beings into the sampling process. So as a result, you are inherently making this a more dangerous operation than an analyzer that is operating by itself remotely. And then, of course, sample purity can be an issue if the if the sample containers are not properly cleaned and maintained as well. So some potential problems there. let's take a look at some sampling system basics. So there are a few different rules of sampling. First of all, we want our sample to be representative, meaning that we want to make sure that our sample is essentially the same as what it is that's in that pipeline. So we want to avoid phase changes, because when we start changing phases from liquid to gas or vice versa, we fundamentally change the sample itself. So we definitely want to avoid that. We want to use probes where we can to make sure that we are sampling from the middle of that pipeline, or and not taking it from the wall of the pipe. Or if you're sampling on the bottom of the pipe, you could potentially be collecting contamination. So definitely using probes helps with the representativeness of the sample. We also want to be timely with our sample. To the extent that we can. Obviously, the grab sampling and the transportation is not as timely as, say, an online analyzer installation, but we still need to be able to get the sample from the process to the panel in a reasonable amount of time. And we need to understand how long that time is so that we know what sort of process corrections we need to make based off of those results. And also, we need to make sure that our sample is pure. We don't want to contaminate the sample. We want to avoid dead legs. We want to make sure that there's adequate purging and flushing. We want to make sure that we use those clean sample containers. Coming back to the dead legs, this is an important point that a lot of people don't realize with regards to sampling applications. We need to make sure that there are no places where old fluid can collect. So, for example, in this particular sampling system, we have our inlet right here, and so our normal flow would be flowing down through here to a sample container that's down out of the picture frame. But notice how it flows past these two T's here, one with a gauge and one on this bypass valve. So right there are 2 points where old fluid can collect and actually doesn't flow. And so as our fresh fluid is flowing down through here, we have some old fluid that is continuously bleeding molecules into that fresh fluid stream, and thereby contaminating our fresh sample. So that's one of the importance of avoiding dead legs. So anytime that we have a pressure gauge or something like that, we want to put that on the downstream side of the sample container. That way we're not contaminating our sample. We also need to understand the behavior of our samples. We need to understand that, again, a gas is compressible, but a liquid is not. And we need to understand what the changes in temperature and pressure are how that's going to affect our sample. So for example, how is, with a liquid sample, as we increase our temperature or decrease our pressure, we can potentially vaporize out some of the lighter components in our sample. So for example, if we have a sample that's here in our phase diagram and we decrease our pressure, what's going to happen? Some of those components might move into the gaseous state. And now again, we've changed phase and maybe potentially fundamentally changed our sample. And likewise, with a gas sample, you have to worry about dropping the temperature or increasing the pressure. Same thing can happen. We can go from the gas phase and condense into a liquid phase. So we definitely want to avoid that phase change because it can and will change the composition of that sample. So anytime we can maintain the sample at the operating or the process temperature and pressure, it's to our advantage, because at that point we're avoiding changing that sample. So we talked about the 2 different types of sample containers, 2 broad categories of sample cylinders and sample bottles. So how do you make the selection between one or the other? Well, cost is certainly a driver. Bottles are definitely less expensive than a sample cylinder. Also, you have to worry about the sample pressure. If it's something that we have to hold at a pressure in order to maintain the process conditions, then a bottle is not going to be suitable, because bottles are not intended to be pressure containing. Also worried about things like toxicity. So the toxicity of the sample is definitely important. Definitely would want to steer towards a sample cylinder in that sort of an application if you have a really toxic sample. It's just a more secure way of transporting something that could be hazardous to personnel or to the environment. And of course, we need to worry about that sample volatility. If we need to hold that sample at pressure in order to keep the liquid from vaporizing, then again, a sample cylinder is the way to go, because again, that sample bottle is not intended to be sample or pressure containing. So looking at an example that most of you are probably familiar with, we have a distillation column here. We've got the basic function of the refinery, right? You got the crude oil coming in, you boil it at the bottom, and then you recondense at different levels, and different products are coming out at different levels. Up at the top, you have your real light gases and things like that, your LPGs, that sort of your methanes, that sort of thing are coming out here at the top. Down at the bottom, you have your real heavy things. Those are always going to be liquid. And then here in the middle, you have your volatile liquids. So this is where you need to worry about what sort of sample container am I going to have. So gases, obviously, we're going to use the sample cylinders. Liquids, we're definitely going to use the bottles, unless it's toxic. But here in the middle, it's kind of up in the air. So we have to look at the vapor pressures and the boiling points. So here, looking at a list of different hydrocarbons, we can see here we've got our atmospheric boiling points for all these different hydrocarbons. And if we look here at pentane, for example, we see it has a boiling point of 36 C. So 36, yeah, we're probably going to be able to get to that boiling point pretty easily, especially down in Alabama. Maybe not up here in Cleveland where we're at, but definitely down there, definitely get to 36 C pretty easily. And so definitely have to worry about that being a volatile sample. Whereas hexane, we got 69 C. Not much chance of getting to 69 C in atmospheric conditions here in the United States or anywhere in the world, really. So really that's about where we draw our distinction there, is between that hexane and pentane. So anything above that line, really need to use a sample cylinder to keep that sample contained. Anything below that line, those are your heavy liquids, your non-volatile liquids, where you're not worried about that sample vaporizing. All right. At this point, I'm going to hand it off to my colleague Eric Kavarda, and he's going to talk about some standard sample system designs that we've developed here at SwageLock.
All right, thank you, Matt, and welcome everybody again. Thanks for the opportunity to talk with all of you. So Matt has explained a little bit about grab sampling basics and some of the great design principles that you look at when you're designing the grab sample system. What SwageLock has done is incorporate some of those basics, some of those design principles, and come up with a standard product line that allows the customer to purchase or specify a grab sample station a lot more easily than having to go through and engineer and design it themselves. What we call this is our grab sample module, which is the GSM. There's two other systems I'll talk about. One is the GSC, which is the grab sample cylinder, and the third is the GSL, which is the grab sample for liquid bottling. And on the next slide, we'll look at one of the main features of the grab sample module is what we call our geared valve assembly. Now what we've got here is a single handle that turns the positions of 3 different valves. So if we were to look at this grab sample panel, and it may be engineered locally or it may be engineered 20 or 30 years ago, the operator may have to come in and turn 2, 3, 4, 5 valves in order to sequence the valve operation in the right way so that the sample is taken in the proper container and it's taken safely. Well, that's a lot of decisions to make when somebody comes up to a panel. So even if the instructions are well laid out right in front of them, there's still an opportunity for that operator to perhaps make a mistake. And as Matt mentioned, if you have some toxic or dangerous liquids, then that could potentially put them at risk. So what we've done is we've combined that function into one geared valve assembly where you can see one handle on there. You can see that picture in the middle has, it's a CAD drawing, it's got some gears that all rotate together and turn those valves to the correct position at once. So a much more safer way to do it than if an operator had to turn multiple valves in a certain sequence. Within the GSM product line, we have different options, so it's a fairly configurable product line. We have two different flow paths. One is a standard flow and one is a continuous flow. We have different selections for liquid or gas. You cannot generally use the same sample panel for a liquid versus a gas application. There's a principle I'll get into in a little bit that'll explain that. For systems where you have something that's very toxic or unsafe and you may want to run a purge line. In the case of a liquid, you could purge it potentially with water or some sort of solvent. In gas, you're generally going to purge that with your plant nitrogen. So we can offer that as an option in the panel. And then of course the cylinder sizes. It's completely up to the customer. There's a wider range of cylinder sizes that are available from small cylinders in 150 cc range up even beyond 1000 cc sample cylinder. Quick connects are the next choice to make. Swagelok has a few different quick connect lines, depending on whether you want elastomers in there or if you need an all Teflon seal in your quick connect, we can provide that choice. And then there's a relief valve option for safety. If something were to happen and the panel becomes overpressurized, this is an area where an operator is going to be standing right in front of that. So if something were to happen and there's an upset condition and the operator is standing in front of that panel, we want to be able to relieve that pressure and certainly not have it potentially harm the operator. And these are our standard designs. And then there's always the custom ones. So one concept, we're not really limited to what you see on these slides here. We can do something that's custom from the ground up or from a napkin sketch. So let's talk about liquid versus gas a little bit. So the main difference between a liquid sample station and a gas sample station, and again, we're talking about sample cylinders here, is that the liquid is going to fill from a different direction. So in a liquid system, you're generally going to want to fill that liquid from the bottom up through that sample cylinder. While in a gas system, you're going to want to fill that cylinder from the top down. The main reason you want to fill a liquid system from the bottom up is there's going to be trapped air in that sample cylinder when you install it. And so that air needs somewhere to go. If you were to fill that sample cylinder from the top down, there's a pretty strong potential that air wouldn't go anywhere. It would just bubble at the top of the cylinder and very, very difficult to flush all that air downward. So in the liquid system, you fill it from the bottom up and it allows the air to easily escape. And if you have an outage tube, it works perfectly with the function of that. The gas system being the exact opposite. If you have any entrained liquids or some dirt or solids in there that you want to flush out, filling that from with the gas from the top down will allow gravity to do its job and take those particles and push them out the bottom of the cylinder. Another feature you may see that's a little bit different here is where the hose is located. Often there's going to be a hose on the grab sample panel. One end of the sample cylinder is going to be tightly fixed to rigid tubing, while the other one's going to have a flexible hose. We always want to have that hose downstream of the sample cylinder. So in the case of the liquid, as the cylinder fills from the bottom up, that hose is going to be at the top of the sample cylinder. The main reason here is that sometimes these hoses, actually quite often, they're going to be flexible metal hoses. So you have a corrugated piece of tubing over maybe a 2 or 3 foot length hose. And Matt mentioned the concept of dead legs. You can see a pretty easy dead leg right there with where that gauge is. And of course, we want that downstream of the sample cylinder. The same concept applies with the hose. If it's a smooth bore Teflon hose, maybe not so much as a concern, but if we're talking about a flexible metal hose with a lot of corrugations, those are very, very small dead legs, opportunity for old fluid to get trapped in there. And then with old fluid, if you're filling it in the opposite direction, that could contaminate your sample, or at least make it a very, very, very long time until fresh sample could be assured to be in that sample cylinder. Another great feature is that these are highly configurable. So if we were looking at our application guide, in other words, our catalog for this product line, we'd be able to go and make a few different decisions and completely configure the standard product on this. So smart part numbers, the GSM, we're making a decision whether it's a gas or a liquid. Is it a standard or a continuous flow? Then there's a pressure gauge, so what's the range on that? We're then selecting quick connects. We're selecting if we want a relief valve or not. And then we're selecting our cylinder size and whether it's a purge system. And I assume mostly here in the United States, we're going to be working with 1/4 inch tubing, but when we're talking about our overseas customers, they generally want to convert that to metric at the edge of the panel. So let's look at what the PNID looks like for some of these systems. So this is the GSM, and it's a standard flow, and it's a liquid module. So this is what the PNID would look like if I were an operator walking up to it. That sample valve, that geared valve assembly would be in the off position. Now, the first thing I'm going to do is I'm going to walk up, and maybe the cylinder is already installed. Often the hose would just be connected to the other quick connect, or there may be a cylinder in there, or I'm going to grab a cylinder out of the bike or out of the truck and install it. And then I'm going to move this towards the sample position. And as we do that, we've got some fluid coming in that inlet, and it slowly fills up that cylinder. A good sample procedure is to wait a little bit of time, maybe 1 to 2 minutes if possible, just to ensure that anything that was in that sample cylinder flows out the top so that the sample you're taking is as fresh as could possibly be. So after the sample cylinder is filled up, I'm then going to turn that position again to the off position. And now the panel is completely isolated. The cylinder valves are not closed, but the panel is completely isolated from the process, and there's no flow going through there. But I can't yet remove the sample cylinder. I need to turn those sample cylinder valves off, very important. Even though the quick connects at the end of the sample cylinder may be what we call a double-ended shutoff that would shut off when they're opened. If you do that at a high pressure, you'll have a couple things going on. One is you get some natural spillage out of that quick connect. And the second is sometimes we'll exceed the pressure rating of that quick connect when it's opened or closed. One thing to be mindful of, the quick connects have a pressure rating when they're coupled, but often a lower pressure rating when they're being coupled and uncoupled. I then switch to the vent mode, and everything upstream and downstream of that cylinder is vented to probably the flare. So it's now we've got a very low pressure in there. Certainly less pressure than the rating to uncouple and couple the quick connects. And at that time, I'm ready to take that sample cylinder out and take it to put it in the truck, put it in the bike, and take it onto the lab for analysis. Now let's look at a slightly different option here. So this is our, two things have changed here. One, this is our continuous flow version. And also we're showing a gas system here. So continuous flow, the main difference is that there's always flow through the panel. It's going in the inlet and coming to the outlet. It's not always going through the cylinder, but there's always flow through the panel. So I walk up and I put this in the sample mode. And I know this is a little confusing to follow, but those three valves that are sort of tied together, that's your geared valve assembly. So all those actuate and change position in unison. Our sample comes through the inlet, and it's routed to the top of the cylinder, where it then fills from the top down because this is a gas sample, and then is routed to the outlet. And I would let this run for a short period of time to make sure that anything in that sample cylinder has been flushed out the bottom. Now I know I have fresh cylinder in there. From that point, I would then turn it off. And you can see the big difference here is you still get flow from that inlet to the outlet. So you have basically a fast loop system that's running right up to your grab sample station. So if this is quite a far distance from your process, you still have that continuous flow, that fast loop that brings fresh sample up to that sample station, and you don't have to worry about purging or flowing out a long stretch of tubing leading up to the sample panel. Next, I'm going to turn those sample cylinder valves off and isolate my gas sample. And then from there, I'm going to go to the vent mode, where, as you'd expect, everything upstream and downstream of that sample cylinder is then vented. You still get continuous flow of your process sample through that inlet and going to the outlet. And the next thing I'll have to do is turn the purge valve on. In this case, this is a sample that we don't want to have our operator come in contact in. Perhaps it's something that's very toxic, so even a little bit of spillage when that quick connect is uncoupled could be damaging the operator. So I'm going to turn the purge system on, which will send, in this case, probably plant nitrogen through there, and purge upstream and downstream and around that cylinder, so that when the cylinder is taken out of the system, everything is going to be isolated within the sample cylinder and within those two cylinder valves. Okay, let's look at the second concept here, which is the GSC, the grab sample cylinder. So often panels are purchased without the cylinder in place. The main reason is our customers would like one grab sample panel, or maybe they would like 10, but they'd like 2, 5, or 50 different grab sample cylinders, because there's often going to be a lot more grab sample cylinders than there are sample panels. So we generally sell those separately. They can be sold together, customized, but we generally sell them a little bit separately. So we have some different options for the GSC based on our 5 standard cylinder sizes, different valve ends. We have different materials of the cylinder, different materials of the valves. Stainless steel 304 or 316 is most common. Manila is also common, although not as common as stainless steel. If you are installing this into a panel with a purge, you need a sample cylinder with a purge option as well. And then again, we have the choice of different swage lock quick connects that could go on there. If it's a volatile sample, you may want an outage tube. You may want a rupture disc also for safety. And then you may want a handle on that cylinder so you can carry it around with ease. Different cylinder treatment or certification options. A treatment may be silk inert coating or Teflon coating. And then it's not uncommon to have stem and body protectors on those quick connects. So the customer can, or the operator can couple something to that. As it's being transported, it's just a better option to keep those safe and keep those protected. And then of course, almost any option is available as something that's a custom solution. Then our third system is the GSL, the Grab Sample Liquid. And this is for the liquid bottle style. So we would not be using this generally for a gas system. Within the GSL system, now we have 7 different standard flow paths, from extremely simple to quite complicated. I'm not going to go over all those 7 right now just for the sake of time. But we do have different options. It's not uncommon for liquid sampling to need a sample cooler, primarily for operator safety. As Matt showed, this could be a glass bottle or a plastic bottle. And if you have a sample fluid that's very hot running through there, you could exceed the temperature rating of some of your elastomers. Or maybe even more importantly, if your operator grabs that bottle with a bare hand, they could burn themselves. So we want to make sure we keep the operator safe. And to do that, we can run a sample cooler upstream. Basically, the first component on the system to cool that sample down to something that's a lot more safe and a lot more manageable. Different bottle sizes, small at 50 cc's all the way up to about 1,000 cc's, and different materials. Viton is pretty much standard. FFKM or CalRes is another option as well. And if we look at one of those flow paths, this happens to be number 6 out of 7. This is one of our more complicated ones, but this is a concept called fixed volume sampling. Now, the idea of the fixed volume sample is to only put a certain volume, a known volume, into that sample bottle when the sample is being taken. The risk here of not doing it this way is potentially overflowing that bottle, which in the case of maybe you're sampling water, that's okay. If you send some extra water out that vent line, maybe you're not too worried about it. You're not going to hurt anybody. But if it's something that you don't want to waste that sample, or you cannot send liquid sample out of that bottle, you want to make sure you have just a specific amount of sample in there, we would look at something called fixed volume sampling. This fills the target of the bottle, I think about 60 to 80%. Again, it prevents some overfilling, and very common from sampling with a high pressure source. So this is what that P&ID looks like. If I'm the operator, I'm going to walk up to that sample panel. They may be a bottle in there, but I'm probably going to get a fresh bottle and install one in that shroud, and there's a stirrup holding that bottle in. Then I'm gonna turn my geared valve assembly, and see what happens here. The sample is coming through the inlet, and it's taking a little bit of a turn at that first valve, and that green cylinder, that's our sample cylinder that's on the panel. Now, it's not a sample cylinder you're going to take off the panel and go to the lab like we saw earlier. This is something that's fixed in there to really provide and maintain that fixed volume. You could probably do that with maybe a piece of large diameter tube, but it's a lot easier to do with a sample cylinder. So this is I'm gonna allow this to flow for a little time, maybe a minute, maybe 2 minutes. It's gonna flush anything out of there that may be old. It's gonna ensure that in that system, there's gonna be fresh sample running through there. And once I'm assured that I have some fresh sample, I'm gonna turn that valve again. Now I'm gonna turn it to the sample mode, which does a couple things. One, it exposes that fixed volume to be able to fill into my sample bottle. And secondly, I'm going to use this purge line. Now, this purge gas is typically lower pressure, maybe only 5, 15, 20 psi plant nitrogen. Even if you have a high pressure liquid that's captured in that fixed volume, as soon as you drop that volume just the slightest bit, since liquids are generally incompressible, it's going to drop pressure. So we don't need a high pressure purge gas to push that liquid out of there. But the purge gas would come in and act in the opposite direction. it would flush all that sample out of that fixed volume, and then simultaneously the operator is going to depress that valve with the blue handle. That's one of our Swagelok 60 series valve. It has a little bit of a spring return on there, to a little dead man's handle. So much like a beer tap, they're going to open that up and they're going to fill their sample bottle with whatever that fixed volume was, and it's being pushed out by the purge gas. So when I'm finished, I have a bottle that's filled to the right level through the right selection of the volumes. I've assured that I'm not sending any of my fluid in a liquid state to that vent line, and I'm properly purged, so I'm ready to take that bottle out and send it on to the lab. And lastly, just a feature of generally the designs that we create. We hear from customers that they love instructions. It's very difficult for an operator to come up to a sample panel that maybe was engineered quite some time ago, maybe by somebody else who knows exactly how to run it, and they want to be able to see step-by-step instructions. So we're happy to put just about as much information that will fit on the panel. Often these are an engraved placard, so that if over time in the weather, if it was silk screened or something like that, it may peel off and become useless. We could put the P&ID on there for you. We could put a bill of materials, spare parts list, all kinds of information that'll make it easy to not only use the panel but maintain and service it when the time comes. So with that, I'm going to turn this over to Karim, who's going to talk about our grab sampling certification program.
So to help, thank you. To help our customers or provide the same level of service globally to all our customers, and we have developed this certification program with the goal to enable our distributors to provide these systems locally. And the certification program basically has created those boundaries for all our distributors and provide them with the tools they need to support their customers. So each of these distributors will go through some extensive training that go along for 8 weeks remotely. And then afterward, they have to come for 5 days at the factory to take additional training on the design themselves, on the tools, and the material that's needed to be able to configure these systems locally. And with these tools and this certification, each distributor is able to quote and build these systems locally. They are also able to, access to BOM generator, like Eric and Matt has mentioned, CAD files and assembly instructions. And also they are able to use our standard material and component to build these systems. And when needed, they have access to our application engineers, such as Matt and Eric, to help support those applications that are not common, or sometimes, in some cases, are challenging. So each of these systems are able to be configured locally, and each of our distributors is able to provide the expertise once they go through those trainings and support their customers. The systems also can be assembled or will be assembled locally to help with the speed and the requirements of the customers, and also make sure that all our distributors are providing the same level of service globally. It keep the sample. Each of these systems has been designed to keep the sample in their representative state. Can be adapted, and they can be configurable, as Eric mentioned, to meet specific needs. So each of this design that you have access to through our catalog can be configurable and changed to meet your specific applications or requirements. They can be easily operated, as you can see from what Eric and the team has mentioned. There is some design element that we have integrated integrated into our systems that make it easier for the operator to manage or to navigate through the systems and operate. One beneficial aspect for all our customers is the part numbering structure. So it's more a smart part number, we call it. So the same part number that you can purchase from any of our sales and service centers can be ordered from a different distributor, and you will get the same systems as long as we follow the same part structure. And each of the systems is also backed by our Swagelok lifetime warranty. The certification program content, so each of the distributors will get access to these 15 designs that can be configurable. They can also be changed, as you can see on the images there, and configurable to your specific need. They are also empowered with tools such as the part numbering configurator, and also they can be designed with third-party components. So if you have a need for a third-party component that you would like to integrate in the systems, certainly all our distributors are able to do so and integrate those components in the system themselves and make sure that they meet your requirements. And also each of the systems would go through the standard tests that are put in place by the certification program. But if there are some tests that you will require that are not as a standard or common, certainly our distributors can accommodate those. One thing to note, I think, as I mentioned, each of these designs can be changed or modified, and I'll go through some of the example, but what you see here is a different configuration than our standard, where all the mounting has been requested by the customer to put in front of the panel for easy access, but also for the locations where they have been specified, they wanted to be able to mount them specifically on some wall and want to have access to the plumbing directly. Some applications where you have a need or there is some media that can expand in the cylinder and you want to be able to extract the sample, there are opportunities to modify the GSC offering and make it more configurable to meet the specific needs of the applications. There might be some applications where you would like to have a combination of coolers, like a third-party component, in addition to enclosures. Certainly, those can be easily integrated and can be generated with CAD files and drawings and specific details and BOM by the distributors and provide those as a package for your need. But also it can be a combination of everything, like the enclosure, the cooling, the heating, depending on specific applications and need and the requirement. As you can see in this example, there is a lot of elements that have been integrated, third-party heaters, and also some cooling mechanism to make sure that they meet the assembly and the system meet the requirements of the specific applications. There are applications where you would like to see some pumps to drive the sample in the system itself. That certainly can be integrated, and it's certainly certain things that we have done and we have experience with, and all our distributors are able to do so. Or it can be something very specific and unique, something that can be challenging for some customers. So what you see here is an ammonia sampler. Customers has some challenges with their applications to sample ammonia and test for water content. And this is a unique solution that we have come up with to help mitigate some of the safety aspect of the customers, but also make sure that the integrity of the sample is kept. And lastly, we have integrated automation aspect to make sure that the steps and are controlled and also are sequenced to meet the specific applications. So definitely certain things that's within our capability and to help support specific applications and those unique, challenging applications that you might have in your plant. With that, I'll open it for questions.
Thank you, Karim. If you guys have questions, go ahead and use that chat feature. We will give it just a couple of minutes here. All right, looks like we have one. For the ammonia sampler, who would the customer require special cables, electronics, etc. for installation? Or would the customer require special cables?
Matt, do you want to answer that, or you want me to answer it?
I can go ahead and answer.
Okay.
So yeah, with that ammonia sampler, that's no special cables required. I mean, it would obviously require electricity out in wherever it's installed. So it just require a single phase power, either 110 or 230 volt, pretty low amperage, 5 or 10 amps at the most. So it's no special installation, no special cabling or anything like that.
Awesome. We'll give it just another minute for any more questions. And if there are no more, we'll wrap up. But let's just give it another second. Okay, do you have sampling systems for very cold liquids, -40, for example?
So the geared valve assemblies that Eric showed, those are actually rated to -65 F, so we can definitely accommodate some colder liquids with those. It's just a matter of making sure that all of the products that are in that circuit meet that requirement. But in general, -40 F, I think that's very attainable. So it shouldn't be a problem.
Awesome. Well, if anyone has any further questions, please feel free to reach out to me. I will send the recording out. Oh, it looks like we have a few more coming in. So sorry. It looks like we have one that says, have you considered running the certification program remotely during this time of no travel?
Yeah, I can answer that. I think that's something that we are currently doing. So we are looking at changing the approach. To your point, based on the remote or the restriction on traveling, etc. But we are definitely putting a certification that can be run remotely, and something that all our sales and service centers are going to see here shortly.
Okay, and then we have another one. Are there spare parts or replacement parts available for the ammonia sampler?
Yes, there definitely are. With that one in particular, that is a product that we are commercializing. It's it has a complete spare parts list and recommended spares, that sort of thing, available. So those are all available. Those spares are obviously all available for purchase, and so that you can have those on the shelf as spares.
Awesome. Well, thank you again to everyone who joined. We will send out the recording this afternoon. If you have any further questions, please feel free to reach out to me and I will make sure it gets answered. But with that, we hope you all have a wonderful day and thanks for attending.